Hello everybody, this is a Radio Dan video. I'm back again to build this kit with you guys today. So this is the ZL3YOTA Morse code training kit. So it's a PCB powered by an Arduino that you can plug a Morse code key into, and it's got some practice exercises and things you can do. And I believe it's also a CW decoder. If you plug it, not a decoder, it will decode what you're sending if you plug it into an Arduino. So we've got here set up the soldering iron. Sponge there. We'll move that aside and we'll open up the kit. So, inside the kit box, there is a very nicely made custom made PCB. Very good screen, silk screen on this. It's a very nice PCB. It's nicely laid out as well. Very easy for beginners. Very nice for beginners because the spacing is not too far apart or too close. So that's quite nice there, and just the back as well. It's got some writing on the back that's basically telling you how the kind of modes of the kit, and also the parts that will come in the kit box. So we're going to check now. We just check we have everything in the box. So we have one Arduino Nano, that's this one here. We have 4 tactile pin buttons, push buttons, sorry, so that's these 4, there we go. We have our 2 adders. Yep. We have 8 LEDs, 2, 4, 6, 8, we do have 8 LEDs, 8 accompanying resistors, and a speaker. So, this is a kit that is, this is a PCB for a project that was designed by someone else. It's available on Thingiverse as well. Thingiverse? No. The original kit was made as an Instructable, which I'll also post a link to in the description of this video, as well as the link to the Trade Me store within New Zealand, where you can buy this kit. So, now with all of our parts here, I will get to assembly. So we have our LEDs here. We'll probably start with these actually. Probably nicest to start with. So, we notice on the silk screen PCB we have a flat side silk screened on. So this the flat here you see corresponds to the negative lead of the LED, which is the shorter lead. So they're all of the same orientation as well. So we put all the LEDs through this way, with the short leads would be corresponding to the flat sides. So I'll put all of those in and then show you the underside of the PCB once I've inserted all the LEDs. I'll show you one LED I'm doing here, so I push them through from this side. We push them through and we just bend one of the leads. Bend one of the leads back so it stays in place. Bend them like that. Display the lead so it holds the LED in place, so you can then solder it onto there. It is best, however, if you solder one joint of the component, solder one joint, and then fold up this leg so it's vertical, and then solder that one, because it just makes it look a little bit more neat. So once we've soldered it, you see, just like that, we've got this leg, we'd folded it down, and then put some solder on there. Then we've got this leg which we hadn't soldered, made it vertical, and then soldered it, heated up the base for 3 seconds, applied the solder, and then lifted off the iron. Just, standard soldering practice. And this kit's actually very nice. The pads are very nicely spaced, so it's very, very simple for beginners learning to solder, and people whose eyes might not be so good anymore, for example. And it's great. It's great as a practice kit as well. Keep your proficiency up while soldering. So I'm going to do the rest of these LEDs and then show you the next step. Right, so I'm not sure if you can see what I've done here. What I've done is I've folded all of the leads up, I've splayed them all out, and then I've put solder on just along one side, so all of these, or all of one side of each of the LEDs is soldered now, right down the line. So these ones we're then going to trim the leads, the excess of this lead off, right back down to the edge of this solder pad basically. Trim all of these off, and then fold these ones so they're standing upright and vertical. So we get one. We'll fold them all up like this, solder them all individually, and then trim those leads off as well. Then we'll be moving on to the resistors. Right, so now we can see our whole row of LEDs is complete, soldered on the bottom. Make sure the pins are not touching, and there's the gap down the middle, you know. There's some flux, I think, spot over the edge. Might need to clean that up later. But for now, that looks fine. They're not touching, they're not shorted, and they're all in the right orientation. So, what we're working on next is the resistors. We have 8 resistors along the bottom that go with each one of these LEDs. We have each 8 resistor here. These are 330 ohm resistors, I believe. Yep, 330 ohm resistors. So, each of these 330 ohm resistors needs to go into these slots. We solder them very similarly to the LEDs, and they go, there is no polarization to these, so you can put them in any orientation you desire. It looks nicer if they're all the same way though. So I'm going to put those in, and then I will come back and show you the next step once I've done that. Alrighty, so with our resistors here, we've got all of the resistors in place. They look nice, all of the colours are in the same directions. And when we flip it over, you'll see I've soldered all of this side along this edge to hold them in place, folded all of these vertical, and then I'm going to solder right down this edge. Then we're going to do our buttons, buzzer, and finally the Arduino. Right, so now with our resistors all soldered in, both rows soldered, we're going to put our buzzer in this socket here. So you'll see one of the holes has a small plus beside it. If we look at the actual component itself, I'm not sure if you can see it on the camera, but there is a plus sign. There you go. There's a plus sign on the component. Plus sign on the component needs to match up with the plus sign on the board. So it goes in plus sign there, plus sign there. We're going this way in this case. The longer lead of components is also usually the positive side, or the anode, and the negative side is the short side of the cathode. So, okay, we'll go, and I'm just holding it wrong because I have to do this one-handed for the camera. So, once I put the buzzer in, we're going to do similarly to everything else. We fold one component leg down, solder it in, make a nice good joint, and then trim the excess of the leads. Right, so that's now our buzzer in place. We then have 4 buttons to go along the top edge for changing different modes and parts of the games. So they go in again, like everything else, we're going buttons down, fold the legs over. So push the component through. And then on the back side, we fold the component legs. Just like that, so we have one vertical and one folded component lead, and the component stays nice and flush and level to the board. It's a bit twisted, there you go. Flush, level to the board, and straight. Alright, so now with our buttons in, buzzer in, LEDs in, and resistors in, the last step is our Arduino. So included with the kit we have this Arduino Nano with it's a USB-C, it's a clone Nano with a USB-C port, and they're quite good. Because micro USB and the mini USB that came in the original ones is hard to find now. But anyway, to fit this Arduino, it goes this way. You see where it says USB lines up with the USB port, so that orientation. And we don't use sockets on here. Sockets don't actually fit on the board, so we go header pin straight into the board and then straight into the Nano on the top. And we want the just normal through the board and then pins on top. So I'll show you that once it's done. Right, so with the header pins we do want to be careful because if they're at all misaligned, it's very difficult to get the board on top. So, how we get around that is we do 2 pins, 1 on each side of the header. We solder 2 in, and then you heat it up and you can move it around if it's not straight. So I've got this one aligned square to the board now. So once I do the other one, we solder down the row, and then the nano then basically just sits sort of on top of the pins, if you will, down the header. Nope. Yep, it's hard to do one-handed, but maybe if we get it from this angle, you'll be able to better see. The nano will basically perfectly align, in theory, with the header pins, with absolutely zero bad choppy camera cuts. You'll be able to get your Arduino sat on the pins and not touching the board, perfectly spaced with the header. But it's not, because it's not soldered and one side's not there. So we're going to solder the other side and then put it on, and we should be good to go. Oh wait, I forgot to mention that we need wire for our key as well. I believe it should work with a paddle as long as you have a keyer to go with it, but if not, then you need a straight key. And I've got an STL I'll put down in the description from Thingiverse, not made by me, just one I very much liked printing and thought was quite easy to print and to put together and assemble and to get it working, that I think would go nicely with this kit if you're going to do it as a workshop. So I'll put that in the description along with the link to buy this kit and the original Instructables project. Now, with both header pins soldered from the bottom, it should look something like this. Now ideally, I mean, I guess you would have put the pins on the Arduino first, but no, it doesn't really matter, you can do them both ways. I've got the long pins coming up, so you'll need to trim them. They're quite high here, so you'll want to trim them down a bit and then solder them. Or solder them first, then trim them down a bit, and then your kit should be complete once you've got two wires going off there. If you're using a straight key, I've seen you can get these jacks, and they're basically an inline female jack for an auxiliary cable, basically, which is what most straight keys are using. So if you get one of those, you can solder that onto a couple of flying leads off the edge of here, and powered through the Arduino USB port, and you use the serial monitor in the Arduino IDE, which I'll show you in a minute, to then control it, or to have some text readouts on your screen. Right, so now we can see I've got the Arduino in, and I have a key. This one's soldered here, and some small pieces of Kapton tape over the top to protect it. Now I'm going to plug this into my laptop, and we can see what it looks like from the serial mode. Right, so I have the laptop here, and I've got the key here and the board here. I don't have the time to make a case right now, so I've just kind of propped it in this plastic one, just so it doesn't short out and anything on the desk potentially. I'm going to plug it in for the first time, see if it blows up. Hopefully it shouldn't. Right, beeping. I guess that means it's started up, done a power up sequence, I guess. So now we're going to download the Arduino IDE, which apparently I don't have downloaded right now. And we are going to test it for the first, test it and see what it looks like in the serial monitor. See if we get any readouts of anything. So as soon as you turn the board on, it goes into function mode 1. Sorry I have to record the screen with my phone, but that's the best solution for now. So basically what it does, when you use the, there's something wrong with the key, so I just have to tap the wires together, but when you send the Morse, it will come up on the screen and it will echo it back to you. Here, you can see that when I send some Morse, or we'll just send an A. Not very good at sending on the straight key, but see, we send an A, send an S, there you go, we'll send a CQ. There you go, CQ, there you go. So that's the echo mode. It repeats back to you what you've said. Right, I realise I should probably show you how to change modes as well. So from here, this will be in mode 1 when you first turn it on. So from mode 1, you then press this bottom switch here, which gives you these 6 illuminated LEDs. The brightest one is the mode you selected, so that's 1, 2, 3, 4, 5, 6. You use the middle 2 buttons here to change between which mode. So we'll start with mode 2 now, which is the, I believe this one is the A to Z Morse, so you send characters A through Z and it corrects you if you make a mistake. And then you press the top button. I believe it's the top one to select it. Yeah, because then it shows you it's there now. So you press the top one to select it. So now in this mode, it's testing your ability to send the letters A through Z in Morse code. So I believe what I can do now is just, I need to hold the key down, but I believe what I can do is just start sending. So oh, key, it's the key, I promise. Oh, it doesn't let you skip until you finish the letter, so run F. Oh, doing the dots. So it's telling you now how many you got right based on the amount of beeps, and if we go over here, we can come to our serial monitor, and it's showing me what I'd done, what I'd sent, where I was supposed to send one, when I had messed up here because I thought you had to send the next character, and then it says I got 22 out of 26 right. So that's what that mode is. Next, I will show you, I believe it gives you a random letter and you have to tap out what it is. So next we have a mode here now, which basically gives you a letter of the alphabet, and you have to basically then, I guess, repeat the next letter of the alphabet. So, for example, we can see now, it will, I need to do something wrong to basically get it to repeat the letter, but we can. So that then give you a letter. So I read it to the da, which is V. So that means I then need to do W, which is. So now it's given me da 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 da, which is Q. So following on from Q, we have R. It's quite easy. F. So then it's G next. G is. So that was a da, one da, which is T. So now we need to do U. That was W, so X, which is there. So that's quite simple there. After this, the next mode along, so that's mode number 3. Mode number 1 was that it just echoes back what you'd sent. Number 2 was the A to Z. 3 was this kind of next letter of the alphabet challenge. Number 4, we have to then use your 4-letter word, and you have to then retransmit them basically. After that, we then have a transmit test, which basically it will tell you in the serial monitor a line of text, and you have to then copy that text. So it's there's a few. There's either the quick brown fox jumps over the lazy dog, wowzer, pack my box with 5 dozen liquor jugs, you betcha, the 5 boxing wizards jump quickly, OMG what a show, or bad boys run over your garden but Violet's gone wild. So they're very common kind of test scripts, I guess. It's kind of stuff that you type in a text editor to test a keyboard or something. So yeah, I guess that's the transmit test, and then after that we have a receiving test, which basically is for you to listen and then copy back. So it'll beep out on here, and then you copy that back. So that's more or less the whole kit. I feel like it's a very good kit for beginners. It's a very good kit for advanced people who want to keep up their Morse proficiency or to learn Morse. It would be a great kit to learn some CAD modeling skills. You know, you don't get a case with it. This is my lazy solution, but I'm sure in the future I might want to 3D model a case for it, for example, to 3D print. So it's good for that, you know, good for teaching how to solder and how to CAD model. And I don't know, I guess it's a very well made kit. It's been very well laid out and thought out. I feel like it's the perfect size. You know, it's not overly large, but it's also not so small that a beginner wouldn't be able to do it, for example. So yeah, I think personally, at least, I believe this kit's one of the nicest I've ever built. You know, not nearly to the same caliber as like a QRP Labs kit, for example, but you know, we're comparing apples for apples here. So I'd say it's a very good kit for what it is. I believe the price wasn't too bad. So I was given this kit for free to review and to build and to show you guys. But I just checked on Trade Me Now. You buy them. I'll put the link in the description. $49 for the full kit. So that's the what I've basically just shown you today. You know, no Morse key, but there's you basically it's the very high quality silk screen PCB and all the components you need to build it. And this is the Morse key I was telling you about earlier that was very nice to 3D print, and I'll put the link to that one in the description as well. So yeah, that's just more images there, but this is the real product. So yeah, I hope you've enjoyed this video, and I hope that you will follow along with this when you're building at home, and maybe that might have convinced you that you need to buy one. So 7 threes for now. Thank you very much for watching, and see you guys next time.